What we need is the help of our friend, the machine learning algorithm. So let's say that this is the algorithm that is going to help us out for this particular problem. Let's call this algorithm Mr. Roboto. Now, Mr. Roboto is going to go through all of these variables, and it's going to try to map out in a systematic way, series of steps, a mathematical or statistical model that will go to determining this particular target variable in the future. So it might transform these variables in certain ways. It might combine them in different ways. It may decide to omit certain variables, but there are any number of ways to combine this information to come up with a mathematical understanding of this particular problem. And what we're going to have Mr. Roboto here do is to encapsulate that understanding in what we call a data science model. So this is going to be the output of our algorithm here, Mr. Roboto. This is going to be a formula of sorts or a statistical model that is going to input these independent variables in the future and output a prediction of what this target variable is going to look like. Why that is important is because in real time, you don't see this. You don't know whether or not a delivery is going to be a good delivery or a bad delivery. What we can do is we can have this model make an informed prediction as to whether or not a delivery might turn out as not a good delivery, and then we can have that prediction be sent to a fleet manager, our fleet manager in this particular instance, to maybe prevent a bad delivery from happening and having a good delivery instead. So this model is going to output predictions to our fleet manager. And it's our fleet manager that is going to take the predictions from this model and try to change something about his operations that will hopefully add more value for the business operation. Now, what's important about having this human in the loop is that we also get some validation on how well this whole process is working. We can take the feedback from our fleet manager here and incorporate that back into our data set, our training data set, so that this process gets better. So after a couple of more iterations, the predictions from this model are going to be a little bit more value add to our customer here, the fleet manager in this particular instance. So I used a caricature here for our machine learning algorithm, but the truth is you can use hundreds of different types of algorithms depending on the data that you have available, the problem that you're trying to solve, how well you want to know what's going on underneath the hood here. There are any number of different algorithms that you can use. There are hundreds that are available. There are a couple of different types that you might come across. So you might come across regression algorithms. You might come across tree-based algorithms, clustering, neural nets, deep learning. You might use any number of these different types of algorithms. You might use them in combination. That's what's known as ensemble modeling, using a number of different algorithms together to solve a particular problem. In choosing an algorithm, a data scientist is going to look at the problem, look at the parameters of the solution that we're trying to create, and pick the best algorithm or the best combination of algorithms to perform this function of learning and deriving a data science model. Now to recap, we're taking training data and we're looking at independent variables as well as dependent variables We're using machine learning algorithms to derive data science model that give us some understanding of the problem and how to make this prediction in the future. And then moving forward, we use that model to make predictions in real time and provide those predictions to our customers so that they can make changes in their operations and create more value for their businesses and for their customers.